Welcome back to Dr. Liu's VCE Chemistry channel. Today, we are breaking down electrolysis and rechargeable cells from the 2018 VCE Chemistry exam. As I go through this, please feel free to correct me if you find any mistakes. All feedback from teachers, parents, and students is greatly appreciated. A galvanic cell is an apparatus that converts chemical energy into electrical energy through a spontaneous redox reaction. Fuel cells convert chemical energy into electrical energy, making them a type of galvanic cell. When secondary cells discharge, they convert chemical energy into electrical energy, which means they also function as galvanic cells. Not all secondary cells have porous electrodes, although some do. Fuel cells aren't always more efficient than secondary cells. When molten sodium chloride is electrolyzed, the cathode supplies electrons to the electrolyte. At the cathode, positively charged sodium ions migrate towards the electrode and gain electrons, being reduced to liquid sodium metal. The silver oxide zinc battery utilizes a sodium hydroxide solution as its electrolyte. During discharge, zinc metal is oxidized by silver oxide to form zinc oxide and silver metal. When the battery is recharged, this reaction is reversed. Silver metal is oxidized back to silver oxide, and zinc oxide is reduced to zinc metal. An energy company investigates the feasibility of supplying energy while reducing greenhouse gas emissions. Solar panels collect energy from the sun during daylight hours, and this energy is used to electrolyze water, to produce oxygen gas and hydrogen gas. These gases are stored separately and then used in a fuel cell to produce energy when required. The diagram below shows a simplified representation of the setup used. Solar panels can be used to electrolyze water. The W electrode produces hydrogen gas. Therefore, electrode W acts as the cathode, the negative electrode, and injects electrons, as it is connected to the negative terminal of the power supply. In an alkaline environment, the hydrogen-oxygen fuel cell's electrode Y is connected to the oxygen tank, making it the cathode. Oxygen molecules gain electrons at the cathode, undergoing a reduction reaction. According to the data booklet, the half equation for this reaction can be written as: a single solar panel produces an average current of 5.20 A and operates for 8 hours. The total charge of electrons, Q, is calculated as the product of current and time in seconds. This total charge, measured in coulombs, is then converted into moles of electrons. Assuming all electrons are gained by water, the moles of hydrogen and oxygen gas produced are calculated using the stoichiometric relationships between these gases and the electrons. The pressure produced by hydrogen can be calculated under standard laboratory conditions using the universal gas equation. The generator operates at an efficiency of 35%. To produce 3,553 kJ of useful energy, the total energy input required is calculated by dividing 3,553 kJ by 0.35. Given that the energy density of petrodiesel is 45 kJ/g, we can then calculate the mass of petrodiesel that must be burned to achieve the required total energy input. To calculate the mass of carbon dioxide released, we first convert the mass of petrodiesel into moles. Assuming that 1 mole of petrodiesel contains 12 carbon atoms, 1 mole of petrodiesel will produce 12 moles of carbon dioxide upon complete combustion. Using this stoichiometric relationship, we can then calculate the moles of carbon dioxide and, subsequently, the final mass of carbon dioxide released. To generate the same amount of energy, the combustion of petrodiesel produces a greater amount of carbon dioxide than a hydrogen-oxygen fuel cell. This is because the fuel cell's only product is water, so it does not emit any carbon dioxide. The section examines electrolysis and rechargeable cells. It is worth 14 marks and accounts for 11.7% of the total 120 marks. Multiple choice, 3 marks, question 1, galvanic versus fuel versus rechargeable cells. Understand their core functions, e.g., spontaneous versus non-spontaneous, power source, and rechargeability, question 9, electrolysis. Identify products at the cathode, where reduction occurs, question 16, half reactions. Reverse discharge reactions to get recharge reactions. Short answer, 11 marks, question 8a. Hydrogen gas, H2, is produced at the cathode, question 8b. The amount of hydrogen gas is calculated with Faraday's rule. Question 8c. Calculate total energy input using efficiency. Use petrodiesel's energy density to find its mass. Use stoichiometry to find the mass of carbon dioxide produced. Hydrogen-oxygen fuel cells are an emission-free energy source, unlike petrodiesel combustion, which releases carbon dioxide. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.